How's it, grade 10? So today we're going on to solving right-angled triangles. We're working from slides 21 to 25 from the trigonometry PowerPoint. Okay, so this is now we're getting down to the crunch of trig, and we are going to use our trig functions to solve for triangles like this. Okay, so the question is saying calculate correct to 2 decimal places. So I'm just going to make a note over here that our answers need to be in 2 decimals. And question A is asking for the length BC. Okay, so we need to find out what that length is over there. Before I start, I want to get my adjacent, opposite, and hypotenuse for our given angle. So here's our given angle over here. They've given us that's 54. Straight away, grade 10s, I want you to pick out your hypotenuse. So your hypotenuse is always opposite the 90. So it must be this side. That's your hypotenuse. Then we can pick out the adjacent because it's the only other side that is next to this angle that's given to us. So this is our adjacent side. And then this has to be the opposite. Okay. So we've got our opposite, hypotenuse, and adjacent for our given angle. Okay, so they want us to find length BC, which is this one over here. And we can see that's our opposite side to our angle. What I'm going to do is I'm going to choose the other side that we know, which is this one here. So we want an opposite, we know an adjacent. Which trig function has that combination of opposite adjacent? It will be tan. Okay, so we know that BC over AB will be equal to tan of that angle there. And I just want to make a note of here so you can see what I did. This was opposite over adjacent. Okay, and that's the one that we want to figure out there. So what is our AB? Our AB is 12 millimeters. So we have BC over 12 is equal to tan 54. To get the BC on its own, we need to multiply both sides by 12 to get rid of it there. So we get that BC is equal to 12 times tan 54. This we can just put on our calculator. Again, grade 10s, make sure that your calculator is in degree mode. So we get 12 times tan 54. And we are going to round off this answer to 2 decimal places. And we get 16.52. And our units are millimeters. Okay, so not too bad with that one. Let's have a look at question B. Question B is asking, we have to find what is the angle C equal to over here. So we can see that we have 54. That little square means 90. That is the one that's missing. So we can use interior angles of a triangle. So we know that angle C will be equal to 180 degrees minus 90 minus 54. And the reason why we did that was angles of a triangle. Okay, and you can just put that on the calculator and we get angle C is equal to 36 degrees. Right, question C. Question C is asking us to find the length AC in 2 different ways. Okay, and I might just continue up here just so everything is on the same page. Okay, so let's have a look at the first way that we're going to do this. So we want to find AC in 2 different ways. So if I have a look here, we want to find this side. Okay, let me put a question mark there. We want to find this side. We were given this side. So which trig function has that combination of adjacent hypotenuse? It is going to be cos. All right, so we know that cos of 54 degrees would be equal to adjacent over hypotenuse. So that's AB over AC. Just want to make a note here for you. So this was adjacent over hypotenuse. Okay, I'm just going to fill in which ones we know. So cos 54 degrees is equal to AB, we know is 12 over AC. That is the one that we want to know. So what I'm going to do first is I'm going to multiply up by AC, and we would get AC times cos 54 is equal to 12. To get the AC on its own, I have to divide by this cos 54. So we get AC is equal to 12 over cos 54. And this I can put on the calculator. So 12 over cos 54. Round that off to 2 decimal places, and we get 20,42 millimeters. Okay, so that's one way of doing it. If we look at the second way of doing it, we have a right angle triangle. We know two sides. We've got this 12 millimeter, and we've just worked out the BC from question A, which is 16.52. So we've got those two sides. 90-degree triangle, we can work out that side using Pythagoras. So Pythagoras would be AC squared, it's your hypotenuse squared, equals the sum of the other two sides squared. So that's going to be BC squared plus AB squared. Okay, so AC squared is equal to BC, we worked out over here, which is 16.52 squared, plus our AB, which is 12 squared. So we get AC squared is equal to, I'm just going to punch that on the calculator. And we get 416,9104. And if you notice, grade 10s, I haven't rounded off my answer just yet. I will only round off my final answer. Okay, so now to get AC on its own, I need to take the square root. What I do to this side, I must do to this side. And we get that AC is equal to, and I'm going to take the square root of that answer. And to round it off to 2 decimal places, we get 20,42, which is the same as how we got it over there. Okay, and we've solved for that triangle. Right, moving on to example 2. Okay, so example 2 is saying calculate correct to 2 decimal places. Question A, we want to find the length of RQ. So this length over here. Okay. So from our given angle, which is this one here, I'm just going to find my adjacent, opposite, and hypotenuse. So straight away, opposite the 90, that is hypotenuse. The other one that is next to this, which is adjacent, must be this one over here. And then that side over there is opposite. And hypotenuse. Okay, so we want to find RQ. RQ is the one that we want to find. This is the given side. So which trig function has that combination of opposite, hypotenuse? It is sine. So we know that RQ over PQ would be equal to sine 24,6 degrees. So RQ was your opposite over PQ, which is your hypotenuse. Let's fill in our information. RQ over PQ, 15.3, equals sine 24,6. To get the RQ on its own, we have to multiply both sides by this 15.3. RQ is equal to 15.3 multiplied by sine 24,6 degrees. Put that on the calculator. 15.3 times sine 24.6. Round that off to 2 decimal places and we get 6.37. Units are centimeters. Okay, not too bad for that one. Then question B, they are asking for us to calculate the angle Q. We have this angle P. We have angle R, which is 90. That one we can work out, angles of a triangle. So this would be equal to 180 minus 24,6 minus 90. My reason for this, angles of a triangle. If we put that in the calculator, you will get angle Q is equal to 65,4 degrees. Okay, question C. We have to find the length PR in 2 different ways. This length over here in 2 different ways. So I'm just going to do exactly what I did with the previous one. I'm just going to break this down. Okay. The first thing I'm going to do is I'm going to have a look. We want to find this side over here. We have this side. We don't know this side. Which trig function has that combination of adjacent hypotenuse? It's going to be cos. So we know that PR over PQ would be equal to cos 24.6 because PR is your adjacent over PQ is your hypotenuse. Fill in our information. So PR over 15.3 is equal to cos 24,6 degrees. PR is equal to 15.3 multiplied by cos 24,6. So PR is equal to, punch that in the calculator, 15.3 times cos 24.6. Round that off to 2 decimal places and we get 13.91 centimeters. So that's one way. Let's have a look at the second way. Because we have a 90-degree triangle and we have 2 sides, we have this one and this one, we can use Pythagoras. So for Pythag, we know that we are going to get PR squared plus RQ squared will be equal to PQ squared. The hypotenuse squared is equal to sum of the other 2 sides squared individually. Okay, so PR we don't know, plus RQ. RQ we worked out over here, which is 6,37 squared, equals PQ, which is 15,3 squared. Let's see what this gives us. Okay, so grade 10s, I'm going to do 2 things here. I'm going to work out what the squares are, and I'm going to take this to the other side and subtract it, just to save space. So if you watch my calculator here, I'm going to take this 15.3 squared, this one, and then subtract this one squared, because if I take it to the other side, it becomes a minus. So minus 6.37 squared. And we get that over there. And I'm not going to round this off. I only round off my final answer. To get the PR on its own, I need to take the square root of the other side. So I take the square root of this answer, and we get PR is equal to, round that off to 2 decimals, 13.91, which is exactly the same as that, centimeters. Okay, last example, example 3. So they've given us this information. They've just told us that we need to determine AD, this side over here. They've also told us that we have to round off to 2 decimal places. And they've told us that AB is parallel to DC. Okay, so those two lines are parallel. If I look inside this triangle ADC, that's 90 degrees, and that's the side we want to figure out. Now, with that triangle ADC, we don't know any of the information. We don't have any angles. The one angle we've got, but that's not going to help us. And we don't know any of the lengths. If I look in this triangle over here, I've got a length, I've got an angle. So maybe I can get some of this information into this triangle. So I'm going to work with this ABC triangle first. And what I'm going to do is I'm going to find this AC side, the length of AC. So I'm going to be working in triangle ABC first. And I'm going to try find AC. Once I've got the length AC, then I've got a length in this ADC triangle. So if we look at the ABC triangle, from the angle that's given to us, which is this 27, I'm just going to fill in my adjacent, opposite, and hypotenuse. So straight away, opposite the 90, this would be our hypotenuse. This here would be our adjacent, and this here would be our opposite. We want to find this hypotenuse side. We are given this one. So which trig function has that combination of opposite hypotenuse? It would be sine. So we know that AB over AC would be equal to sine 27 degrees. This was opposite over hypotenuse. Fill in the information that we have. So AB is 10 over AC equals sine 27. I'm going to multiply up by the AC. To get the AC on its own, divide by the sine 27. Put this on the calculator and we can solve for that. So we get 10 over sine 27, and we get, round that off to 2 decimals, we're going to get 22,03. And don't worry about the units because they haven't given us any units. Now I know the length of this AC side, which is 22,03. All right, so we're getting there. Now, I need another angle in this triangle, in this ADC triangle. This is where we're going to use our parallel lines. So you can see here, I'm going to use co-interior. I'm going to make a C there with my parallel lines. So here's our C. And we know that co-interior angles add up to 180 degrees. If I call this angle C1, so I'm going to write this here. We know that angle C1 plus angle, this angle 27, this plus this angle must be equal to 180 degrees. Our reason for that is co-interior. Co-interior angles, and I'm just going to list the sides that were parallel, AB parallel DC. Plug that on the calculator and you get angle C1 is equal to 63 degrees. Cool. Just going to continue on the same page. So we've got everything here and we can see what's happening. Now we know that this angle here is 63 degrees. I can work with my ADC triangle. In triangle ADC. Let's fill in now our hypotenuse, adjacent, opposite from this angle now. Okay, so we're working in the ADC triangle. So opposite the 90 is your hypotenuse. The adjacent side for this one would be this side here. And I've just color-coded these guys so you can see with the blue, that's your opposite adjacent and your hypotenuse. For the orange, that's your adjacent and that's your hypotenuse. Then we just got the one left, which is your opposite. Okay. We know what our adjacent is for this angle. It's this 22.03. We want to work out our opposite. So which triangle or which trig function has that opposite adjacent combination? It'll be tan. So we know that AD over AC will be equal to tan 63,1 degrees. Fill in our information. AD over AC, which is 22,03, equals tan 63,1. AD is equal to 22,03 multiplied by tan 63,1. Punch that on the calculator and we will get 22.03 multiplied by tan 63.1. Round that off to 2 decimal places and you get 43,42. And don't worry about the units because that didn't specify to us. Okay, grade 10's not too bad. Try and color code it like this so you can see, so you don't get mixed up with your different adjacents and hypotenuse, and you can see how they change for different triangles and stuff like that. All right, anyways, I'd like you guys to do exercise 5.6 for me, please. Numbers 1, 2, 3, 4, and 5. Thank you.